Very good morning to all the students. Myself, MM Shoshinpi. Today we are uh, we need to cover on the topic on methods of improve the gas turbine efficiency, and there are basically three methods. One is a intercooling, another is a reheating, and there is a regeneration. There are three methods. First one is intercooling, second one is a reheating, third one is a regeneration. Okay, these three methods we are using to improve the basic gas turbine cycle. Okay, here some percentage of the gas thermal efficiency has to be improved by implementing these methods. Let us we discuss one by one. That is the first one is that is intercooling. Okay, we'll be discuss here only perfect intercooler. Okay, let me discuss later what do you mean by perfect intercooler. And in this we need to understand flow diagram, TS diagram, and thermal efficiency. Let us start flow diagram, how it is there. Okay, basically in the intercooler, what do you mean by intercooler? It is nothing but it is just like one heat exchanger. It will be reduce the temperature from high level to the low level. Okay, and intercooler, this one here in the intercooling method, and it will involve two kinds of the compressor. One is a LPC. LPC means what, a low pressure compressor, and HPC means what, a high pressure compressor. In between you can observe there is a intercooler. Okay, let us here at the point one, here is a inlet that will be transferred to the water low pressure compressor. It will be get, okay, compressed, and what is the get this is a temperature has to be raised, and rise temperature passing to the what here intercooler, and then it will be reduced to the temperature T3. Now you can observe that is either below you can observe this one here T1. Okay, we are passing to the inlet, and this is passed to the what first LPC compressor. It will be raise the temperature T2, and once it will be passed to the what intercooler 2 to 3 process, again temperature is equals to T1, nothing but T2. Okay, whatever rise, it will become to what a original temperature T1. That is nothing but what intercooling, and this method we can calling as what a perfect intercooler. And point 3 again it will be passing to the what pass to the high pressure compressor. Okay. After this one compressed air, okay, it has to be passed to the what combustion chamber. Here, fuel has to be added, and combustion process will be taking place at the point of 5. Okay, inlet of the water gas turbine. That means 5 is the exhaust gas that is goes to the turbine. There is a output work will be formation. That is enthalpy decreases to the water 5 to 6 output work you can get it. Okay, like this you can exhaust the out at the point of 6. Okay, now this flow diagram we need to transfer, we need to transfer to the water TS diagram. Okay, refer the what here, this is a flow diagram. This 1 to 2 process. Okay, this is adiabatic compression process. 1 to 2 you have a this is a low pressure compression process, and 2 to 3 is we can call as a intercooling process. Because of perfect intercooler, this 2 is okay reduced to the 0.3. There's a as equal to is a 0.3. T1 is equal to T3. If it is T1 is equal to T3 and T2 is equal to T4, that that intercooler we can call as a perfect intercooler. At point 3 again we are passing to the water that is a high pressure compressor, and that's what temperature rises to what point 4. Okay, and point 4 pass to the combustion chamber, heat will be addition, okay, taking place 4 to 5. That means temperature increases and entropy increases. At the point 5, okay, you get a expansion process in the this one here expansion process in the turbine. That's what 5 to 6 is the ideal. Now there's a 6 to 1 we can call as a heat rejection, and temperature decreases and heat also reduces. Okay, and this entropy also reduces. Now I have shown this one in dotted lines. with respect to what I explained 1 to 2, 2 to 3, 3 to 4, and 4 to 5, 5 to 6. These are the ideal process. And here only sometime you need to calculate this one here actual basis also. That's what this problem we need to draw with the actual basis also. 1 to 2 dash is the actual, because of this entropy not remains constant. Okay, now that is a 3 to 4 dash here also actual, and 5 to 6 dash also here also actual. Sometime you need to this why intercooling is required. Sometimes they ask question. See, you can observe this is what here without intercooler you can see 1 to a ideal process. Okay, directly we need to get the what high pressure. It's a very difficult getting the what high pressure from the what compressor work will be require more. That's what we have to reduce that is a rise of pressure in the two stages. That is nothing but a intercooling method. Okay, you can observe from the TS diagram 1 to a. Okay, compressor work will be required more. Okay, this is a ideal case. And here also 1 to a dash is a actual case. Okay, now 1 to a to 5. Okay, 5 to 6, 6 to 1. This is a without intercooler. Okay, in the actual case 1 to a dash to 5, 5 to 6 dash, 6 dash to 1. This is what actual cases. Okay, now you can compare the efficiency this with regeneration, without regeneration, with respect to ideal as well as actual case. Okay, based on this one here, I hope all of you understood this TS diagram. Okay, let us, we have going to write the equations. Uh, this thermal efficiency with intercooler and thermal efficiency with the without intercooler. Okay, let us write this one here. Thermal efficiency with intercooler. That is the first case, ideal case. Ideal case that is equal to net work divided by heat supply. Okay, ideal, you just remember there is a okay this one turbine work cp of air. Okay, mass we have considered 1 kg. Okay, cp t5 minus t6. Okay, minus what you have to consider this one here, compressor work. Compressor work, it is a two stage. Okay, there is a cp t2 minus t1 plus you are going to add, because there are two turbines here, 1 to 2 and 3 to 4. It is a compressor is 2 tp t2 minus t1 plus cp turbine work minus that is a sum of the okay 2. Sometime this we can write 2 times of cp into t2 minus t1, because t2 is equal to t4, t1 is equal to t3 for intercooler, and again heat addition with regenerate with the intercooler, that is cp into t5 minus t4. Okay, now this in this you can write for the actual case. Okay, just you need to change it. Okay, ideal to there is a actual case, network divided by heat supply. That is now turbine work cp t5 minus t6 dash minus sum of the what here low pressure compressor, and next one is the high pressure compressor cp t3 t2 dash minus t1 plus cp t4 dash minus t3 divided by heat addition cp into t5 minus t6. Okay, you can get the difference how to write the thermal efficiency equation for the ideal case as well as actual case when you writing for the what efficiency equation with intercooler. Sometime for comparatively, okay, they may ask efficiency without intercooler. They may ask the questions means how much percentage has to be improved by the intercooler. Sometime question will be asked. That's what you must know this one here, how to write the equation without intercooler. Already I explained without intercooler, that is you can observe in the TS diagram. Okay, 1 to a to 5, 5 to 6, 6 to 1. This is just like a simple gas turbine. Okay, there is nothing but this cycle we can call as a okay, previous problems you have seen. This is what you have written this efficiency equation. Okay, and now you can write this one here, ideal case as well as actual case. Okay, now without intercooler, wt minus wc and qs. Okay, now ideal case, that is what is the turbine work in this one here, that is Cp T pi minus T6 minus only one compressor work, that is we have a Ta minus Cp into Ta minus T1. Okay, that is whole divided by heat supply. What is the heat supply here? In this, just you can see this one here. Okay, cycle. I have shown this is only T pi minus T. Okay, and similarly, okay, you can write for the, this is the case of the actual case also, and the network load of heat supply. Just you need to change the what here actual. Wt is we are calling as a T pi minus T6. Okay, minus Cp into, okay, what is the this one here actual turbine work, Ta dash minus Ta1. Okay, and divided by heat supply, that is a Cp into Ta minus Ta dash. With respect to, okay, Ts diagram, we are going to write that is, okay, that is without intercooler. Okay, you can write equation for the ideal case as well as this is the actual case. Okay, I hope you are all of you understood. Let us stop now here, and after this I will start this one or two problem with related to this basic concept of the water intercooler. Thank you.